These two power stations can do something that no other power stations can do. These guys are from DJI, the same company that makes the popular drones, and they can fast charge DJI drone batteries through a special port that's on these two. So in this video, I want to show you the new DJI 500 and the new DJI 1000 in case this is something you're interested in getting. Now, both of these are not only new to the market, they are DJI's first power stations that they've ever made. Now, full disclosure, DJI did send these to me for review, but everything in this video is my own opinion. So these two power stations look a lot different, but there is a lot of commonality in terms of features with both of them, which I'll go over. But in terms of a high level of some of the differences, the DJI 500 is 512 watt hours of storage capacity. It's obviously smaller. This one is double the storage capacity. This is the 1000. It has 1024 watt hours of storage capacity. The other main difference is that this one has one of these special ports, which I'll show you. This one has two of these special ports. And then the inverter is the other big thing other than the physical size. The inverter output over here can do 4400 watt peak surge and a 2200 watt continuous. I'll show you how that works. And then this one over here, obviously being smaller, has a smaller inverter. It can do 1600 watt peak and about a 1000 watt continuous all the way down to 20%. And then you get 800 watts. So one of the things that means in terms of practicality is that if you were going to use one of these to do power backup at your house and you wanted to run your full-size refrigerator in case there's a power outage, then the DJI 1000 has the inverter that'll be able to do that. For most people, their full-size refrigerator, that 1600 watt peak coming out of here is not going to be enough. And a quick look at the exterior on the 1000. There's a flat top with two handles. There's no wireless charging up here, and the vents are on either side. And for the 500, the handle is in the back, air intake on the sides, exhaust is in the back, flat top, no wireless charging pad, and the inputs, outputs, and the screen are all on the front. So some other notable differences between these two. This one's obviously smaller. It weighs about 16 pounds. This one weighs about 28 pounds. They both have two USB-A ports and two USB-C ports, but the USB-C ports are different on these units. This one can output two at 140 watts each. That's sort of a unique thing with this guy. But this one can only output 100 watts power delivery on each of these two. However, it can also be an input. So you can input 200 watts, 100 watts each. All right, there's some other minor differences, but let me focus in on what is common to both of these. They both use the battery chemistry, lithium iron phosphate, and they have a high cycle life, which they are both rated for 3000 cycles down to 80% original capacity. And so what that means is if you start at 100%, drain the battery all the way to 0 and recharge it back up to 100%, that counts as one cycle. These are rated for 3000 cycles. So what they are rated for is about 8.22 years if you did one cycle every single day, and then the original capacity of the battery will be 80% of the 512 watt hours or 80% of the 1024 watt hours. That is a very long-lasting battery, and LFP is a very safe chemistry. When you turn these units on, you're greeted with the familiar DJI starting chime. If you heard that, screen comes on. Screen is very nice, has two different colors, state of charge, a little progress bar, input and output wattages you can see at the same time, and there's some other data that will show on the screen depending on the input. You can input and output at the same time with this unit. So I'm going to turn on the AC inverter so you can see we're at 60 hertz and we are at 121.5 volts. That's all within the normal range. So I've been charging the DJI 500, which is up here. It's inputting about 620 watts, and you can see the state of charge. And then also down here, you can see the time estimate remaining until this goes to 0%. It says 87 minutes. And now when I'm charging, it will show the opposite, how much time is left to get from its current state of charge up to 100%. So one of the unique edges that the DJI power stations have over others is that they can charge DJI drone batteries at a faster rate than just using the USB-C or the normal charging method. And that is done with these ports right here. There are two of them on the 1000 and one of them on the 500. They call this the SDC port, or short for Smart DC port. That's what I've heard. These are input and output ports. And by the way, these doors are very nice on both of these units. But this SDC port is keyed. You can't get it wrong, and you can get a number of attachments. So they just plug right into here. And one of the attachments that you can get is one that charges your particular battery. So if you look on the screen here, there's currently 4 batteries that can be fast charged. I don't know if they're going to expand that in the future, but depending on the battery, if you have the right connector, it looks like you can get most of the charge in about 30 minutes. So with these power stations, one of the things that DJI has chosen to do is not offer the typical outputs or inputs that would be on a power station. So for example, there's not a 12-volt car adapter output on this, nor is there a native solar input like an XT60 or an Anderson input. They've done that all through these STC ports, and then you have to get adapters to be able to do that. So for example, here's one for the 12-volt car output if you want to run a portable refrigerator. Here's another one that if you want to charge from your car, or if you want to charge by solar panels, you can get one of these MPPT adapters. It has 3 XT60 inputs, and this whole thing can input 400 watts of total solar power. So this device can handle 800 watts of solar with 2 of these inputs, and the 500 can handle up to 300 watts of solar. DJI sells their own 100-watt solar panel that works with their units. Very easy to set up, and it's lightweight and has an XT60 connector on the end. But you don't have to use a DJI solar panel as long as it fits within the specifications. For example, here I'm using a 200-watt solar panel to charge up the unit. And when you have solar hooked up, not only can you see the input wattage, but at the top you can also see the actual voltage input, which I think is pretty cool. You can charge both units directly from a wall AC right behind this door. Each of them has a toggle switch for fast charge and slow charge. I always recommend charging slow charge if time doesn't matter to you. Just in the outside chance you want to keep temperature lower on the battery cells by charging slower. But even if you charge faster, it's not going to be a problem because there's a battery management system inside of here that's going to help preserve the life of the cells. But when you put these units into fast charge mode, they are advertised to charge from 0 to 100% in 70 minutes. When I did a test, I actually charged it from 0 to 100% in 65 minutes. That's 5 minutes faster than the claim, which is always a good sign. Both of the units have a UPS mode, which means it can switch over from wall AC to battery power within 20 milliseconds. To test that, I have the wall AC plugged in. I have the AC inverter on running this laptop. And you can see the white screen here. There is no battery in this laptop, so it's running completely off of AC. So I want you to keep an eye on the screen to see if this laptop shuts off or if there's any flicker on the screen when I unplug the wall. This is going to simulate a power outage. So I didn't see anything on the screen. Laptop is still running, so it switched over within that 20 milliseconds and kept everything running. So a notable item about these 2 units is how quiet they are. DJI says that they've put larger fans in here and a design to make it as quiet as possible. I have a dBA meter right up here. I'll show it to you. I am running a test outputting about 1,000 watts, and it is a 1 kilowatt hour battery at 1,000 watts, which means it'll deplete itself in about an hour. The upper decibel range is supposed to be about 28 dB when you're 100 centimeters or about 39 inches away. But even if I stop talking with the microphone pointing right next to the fan and the room quiet, I'm getting a decibel reading as low as my meter will go, and I get the same reading about 4 feet away. So my takeaway is with 1,000 watts of continuous output 3 to 4 feet away, you can barely make out the fans are running. I mean, I can feel the heat coming off of here, but I can barely tell that it's running. I've got some hard drives behind me. I can hear those a lot more clearly than I can hear the fans in this unit. So both units are very quiet when you're not pushing them to their limits, but if you are pushing to the limits and the heat is hot enough, the fans are going to kick into high gear and you are going to notice them. So I've been running this from 100% down to 79% currently at 2140 watts, so it does look like you can get a consistent 2200 watts of output on the AC inverter. So let me turn it up and we'll see when this goes into overload. It's maxing out at 2500 watts and it's beginning to beep. I don't know if you can hear that. And there it goes, it shut off. It says error 62, which is what I expect, and it says overload. So that's a good sign because the inverter lasted about another 30 seconds when I pushed it beyond its specifications, and then it went into overload. I'd mentioned the inverter on here was strong enough to run a full-size refrigerator. That's what I have right here. I'm going to run a test simulating a blackout to see how long can this run our full-size refrigerator for our family of 7 while we're using it. All right, so the compressor just kicked on. I didn't hear any noise coming out of the 1000s. That's really good. It's able to handle that power surge needed to start the compressor on the fridge. So after using the refrigerator as normal throughout the day, the 1000 had no problems, and it ended up being able to run the refrigerator for 5 hours and 3 minutes. So the specification that I found interesting about the 1000 is that it says it can handle up to 220 pounds on top of the case. So they designed it to handle a bunch of weight. So in addition to that, if you want to protect your 1000 from the elements while you're on the go, they do have this travel bag that has water resistant zippers and access to all the ports and some pockets, and then you can carry it around. There's even vent openings here for the airflow. So something else about the 1000 are these threaded connections right here. When I first got this, I didn't know what these were for. I assumed it was for being able to secure this down to something more solid, and I assume you could do that, but its intended purpose is if you get this MPPT adapter, it fits on there, and it does come with the 1/4-inch threaded screws, so if you do want to attach it this way, here's what it would look like. Looking at the 500, this one has the advantage of being much lighter at 16 pounds, more portable, and notably it has two 100-watt USB-C ports that can be used for input or output. So let's try charging through both of them. Unfortunately, I don't have two cables rated for 100 watts. I only have one of them. You don't quite get 100, you get about 90, at least in my tests. So with these two, I'm getting about 150 watts of input across both of these USB-C ports. So that's kind of nice. One thing that you can't do is you can't dual charge. You can't dual charge DC and AC at the same time. So in terms of AC efficiency, I ran some tests on both of these. What we're trying to measure is the efficiency of the AC outputs when the battery is 100%. So what I did was I put a load on each of these that would drain the battery in about 1 hour. So for this guy, it was a constant load of about 500 watts, and this one was a constant load of 1000 watts. The best AC efficiency I got for the 1000 was about 82.5%, which is good. And for the 500, it did a little bit better at 85% efficiency. So what are my final thoughts about these units? Let me know what you think down in the comments below. I think these are definitely solid machines, power-wise, great build quality, they're very quiet, yet DJI seems to have made design choices that gear these towards a specific audience. For example, the lack of a 12-volt car output or not natively including a solar input on either one. They do have these input and output ports. They're nice, so you can get the correct adapter for your particular drone battery to fast charge them. And they also offer the flexibility for future features. So it does make sense to have these, but I wish they had a native solar input at least. And on the 1000, I was hoping for more than just two AC outlets, but I guess you can always get a power strip and plug it in if you need more. Something else that DJI didn't make available is a smartphone app. Maybe they can add that in the future, but it's not currently available. You can upgrade the firmware on each of these units using your computer and a USB port. I did that and didn't have any issues. Prices seem to change regularly. I was just told yesterday of a new set of discounts coming out. So check the video description. I'll keep it updated with any latest deals that I can find. And I want to know what you guys think about these power stations. DJI entering the market, being able to fast charge the certain set of drone batteries with this port, and not having a smartphone app or some of those other things. Does that even matter to you, or is that a deal breaker for you? I'm very curious what you think about these units. Post any questions or comments down below.